Hi everyone and welcome to this video lecture. The purpose of this video is to demonstrate how to run what's called a paired samples t-test in SPSS. Now the paired samples t-test that I'm going to show you now is a different type of t-test to the one that I demonstrated in the previous video. So it's really important that you pay close attention to this video so that you can understand the differences between the paired samples t-test that I'm showing you now and the independent samples t-test that I showed in the previous video. Although they're both called t-tests, there are some crucial differences between the two types of test, and you need to know when you should run a paired samples t-test and when you should run an independent samples t-test. You also need to know how to run both of these types of tests in SPSS, so it's really important that you watch this video and make sure you know how and when to use a paired samples t-test. Now, a paired samples t-test is classified as a difference test because it tells us whether or not we've got a statistically significant difference between two sets of data. We use the paired samples t-test specifically when we've got two experimental conditions and one independent variable, and we want to know if there are statistically significant differences between the two conditions. The key thing to remember is that the paired samples t-test is used when you have a repeated measures experimental design. So the type of t-test that you use depends on the design of your experiment. If you've got an independent measures design where you've got different participants in each group, then you do an independent samples t-test. If you've got a repeated measures design where you have the same participants in each condition, then you do what's called a paired samples t-test. So as an example, if you recruited a group of participants and you got them to complete a test on the first day under one condition, you then sent them away, brought them back the following day and got them to complete the test again but under a different condition, you would have a repeated measures design because all participants would be taking part in both conditions, and therefore if you wanted to know if there was a significant difference between your two conditions, because you had a repeated measures design, you would need to run a paired samples t-test. So let's imagine that this is our research question and that we've conducted an experiment to test it. Do pre-performance routines improve basketball free throw performance? If you're not aware, pre-performance routines are a consistent set of behaviours and cognitive processes that athletes go through prior to executing a self-paced skill. So in basketball free throws, you'll often see elite players executing pre-performance routines before shooting the free throw, and this will involve them perhaps bouncing the ball a couple of times, spinning the ball around in the air, and then shooting the free throw. So they'll have a consistent set of behaviours that they follow. They'll probably also have a consistent set of psychological strategies that they go through. So they might imagine themselves executing the free throw successfully. They might pick a specific point on the rim that they focus on before they shoot, things like that. And there's some evidence in the literature that these types of routines, these consistent behavioural and cognitive patterns that people follow before executing a skill, might be beneficial for improving performance. So let's imagine that we've tested this research question by recruiting 20 participants who are all novice basketball players. We test them using a repeated measures design. So we first get all 20 participants to shoot 10 free throws without using any form of pre-performance routine prior to each shot. So that would be our no pre-performance routine condition. Then we could get the same participants to come back and shoot 10 free throws again, but this time using a specific pre-performance routine prior to each shot. This would be then called the pre-performance routine condition. So we compare them without the pre-performance routine and with the pre-performance routine, the same participants in each condition. During those two conditions, what we would do is calculate the number of successful shots that each participant made in each condition and enter that data into an Excel spreadsheet. We would then run paired samples t-tests to compare if significantly more shots were scored when people used a pre-performance routine compared to when they didn't use a pre-performance routine. Okay, so let's imagine that we've now run that experiment and we've entered that data into an Excel spreadsheet. So here we've got our participants, 1 to 20. Here we've got the scores that each participant achieved when they were shooting their free throws without the pre-performance routine, and then in this column we've got the scores that the participants achieved when they used a pre-performance routine. So you can see here, this row contains participant 1's data without the pre-performance routine and with the pre-performance routine. The next row contains participant 2's data without the pre-performance routine and with the pre-performance routine, etc. We've got 20 sets of data which we can calculate the mean and standard deviation values from, and then we can use that to create a graph like you can see on screen here. But as we've discussed previously, we can't just look at the differences in the means and look at the differences in the graph visually to determine whether or not we've got a statistically significant difference. We've got to run some sort of statistical test to tell us whether or not it's a real significant difference between the two sets of data. So the way that we would do that is using SPSS statistical software package. So if we go to the Start menu and open up SPSS, you're looking for a program called IBM SPSS Statistics 25, and when you click on that it would open up this box. Same as what I showed you in the previous video, you would first click on New Dataset and then click on Open. That would then open up this spreadsheet here, this SPSS datasheet, and as I mentioned in the previous video, this looks a bit like an Excel spreadsheet, but it's different because we've got these two tabs at the bottom, the data view and the variable view. The data view, as I mentioned previously, is where you will eventually enter your data, which we've got currently in our Excel spreadsheet. And remember, the golden rule of the data view is that each row represents one participant. So all of the data for participant 1 is going to go in row 1, all of the data for participant 2 goes in row 2, all of the data for participant 3 goes in row 3, etc. The other view that we need to remember is the variable view down here at the bottom. So if we click on that, this is where you specify your variables so that the software package knows what your data represents. The data is just in numerical form, and the software package doesn't know what those numbers mean unless you tell it what those numbers mean in this variable view. So before you go into the data view and start copying your data in, you first need to go to the variable view and specify your variables. So what we would do for our experiment is first of all go to row 1 in the variable view and specify our first independent variable. The first independent variable in this experiment was when participants shot without using a pre-performance routine. So we could call that no PPR, for no pre-performance routine. Remember that SPSS variable view doesn't let you use spaces, so you would use an underscore to separate the two words here. There's no need with a repeated measures design to specify the values like we did for the previous type of t-test, and the reason for that is because we haven't got participants in different groups, so we don't need to specify the values here. What we do need to do though is specify what our second independent variable was, and in this case it would be when participants shot using a pre-performance routine. So we can call our first independent variable no PPR, we can call the second one PPR for pre-performance routine. Once we've done that, if we flip back to the data view, you can see we've now got no PPR in column 1 and PPR in column 2. So no pre-performance routine data is going to go in this column, the pre-performance routine data is going to go in the second column. So if we flick back to our Excel spreadsheet, we can then copy the scores for the 20 participants when they didn't use a pre-performance routine. We can copy that data and we can paste it into our SPSS datasheet under the no pre-performance routine column. We can then get the second column, the pre-performance routine data, copy it and paste it into the pre-performance routine column. So dead easy with the repeated measures design. You don't need to specify the different groups. You can just label the two independent variables and then copy the participants' data into the data view as I've just shown. If we want to analyze that data, we do similar procedure to what we do for the independent sample t-test. We go to analyze, we go to compare means, and then this time we choose paired samples t-test because we're trying to run the paired samples t-test with our repeated measures design. If we click on that, it will bring up this box where we can specify our two different variables. So we'll tell it what are the two pairs of variables that we want to analyze. The first one is no pre-performance routine, so we put that in as variable 1. The second one is pre-performance routine, so we put that in as variable 2. Once we've done that, we can press OK, and it will run our paired samples t-test for us. That brings up a box that looks like this, very similar to the one we looked at for the independent samples t-test. The first box is called the paired sample statistics box, and in that box it tells you your kind of descriptive statistics. It tells you the mean scores that participants got when they didn't use a pre-performance routine and the mean scores that they got when they did use a pre-performance routine. It also tells you how many participants were in each condition, 20, because it's the same participants in each one, and it tells you the standard deviation values as well. The second box we can ignore for now. It's not necessary for our paired samples t-test. The third box down here, the paired samples t-test box, contains the results that we need. The p-value is this value here, the significance value. And that, as you know, tells us if we've got a statistically significant difference or not. So if this value is less than 0.05, it means we've got a significant difference between our two conditions. In this case, it's 0.005, so it is lower than 0.05, and that means there's a statistically significant difference between our two conditions. And as you can see, they scored less in the no pre-performance routine condition, 4.9, than they did in the pre-performance routine condition where they scored 5.8. So we could say they scored significantly more baskets when they shot using a pre-performance routine compared to when they didn't have one. As well as the p-value and whether or not that's below 0.05, we also need to take the t-stat score from here and the degrees of freedom score from here. So in the paired samples t-test, it's these three: the t-value, the degrees of freedom value, and the significance or p-value that we need for writing up our results. Okay, so in terms of how to write up the results of our t-test, it's similar to what I showed you in the previous video. So first of all, we have our graph, but we can't just look at the mean values in the graph to work out whether there are differences. We have to look at the values that were specified in the SPSS output sheet. So as you saw previously, there was a statistically significant difference because the value was below 0.05, it was 0.005, and we also said we need the t-value and the degrees of freedom value. The way we write up the results of our paired samples t-test is as you can see on screen. So we could say participants scored significantly more baskets when using a pre-performance routine compared to when no pre-performance routine was used. And we can then specify the mean and standard deviation scores in brackets where appropriate here. We then need to write up the statistical information, as you can see here, on screen. So we put the t value, t, brackets, the degrees of freedom, which is 19, equals whatever the t value is, rounded to 2 decimal points, followed by the p value, which we've got here. So t, brackets 19, because 19 is our degrees of freedom value, equals 3 minus 3.22, because that's what the value is in our t box, and p equals 0.005, because that's the value in our significance box. We could then add to the graph these little asterisks and the drawing tools to create this indication that there is a statistically significant difference between the two data sets, so that someone could read the information in our results section and they could also look at the graph and see that there was a statistically significant difference between the two data sets. Just remember as a final point that if the SPSS output had shown the significance value to be 0.000, the reason it's done that is because it only shows to 3 decimal places in SPSS, and the p-value would actually be even smaller than that, so it gets rounded down to 0. But it can never be exactly 0, so if the p-value had been 0.000 in SPSS, we would have written it up as p is less than 0.001. Okay, hopefully that video has all made sense. There are some subtle differences in how you set up the variable view and how you enter the data and how you run the test when you're doing a paired samples t-test compared to when you're doing an independent samples t-test. The choice of each t-test is determined by whether or not you've got an independent measures or a repeated measures design. You need to make sure you're familiar with which type of test you run for which type of design and how to run and interpret both of those types of t-tests. Okay, that's it for me. Thanks for listening.